continue studying the photoelectric effect, and we're going to throw in a little bit of math. We said these are always going to be conservation of energy problems. And we have to figure out how to find the energy of a photon of light. So the equation we're going to use is the energy of the photon is equal to hf times on the frequency, or we can use hc over lambda. H is a constant. It's 6.63 times 10 to the minus 34th joule seconds. And if you remember, c is the speed of light, so 3 times 10 meters per second. So here's an example problem. I have light with a frequency of 4 times 10 to the 14th hitting the surface. Gives me the work function. We have to see if electrons are going to be emitted. If they are emitted, we want to find their speed. So obviously I could draw a picture to help me organize my thoughts. So my work function over here is equal to 2 times 10 to the minus 19 joules. And my frequency is 4 times 10 to the 14 hertz. And as I was saying, these are always energy problems. This is an energy, so it's okay, but this frequency up here is not an energy. I have to use that frequency to find the energy. So I'll use the equation E equals hf. 6.63 times 10 to the minus 34th is h, and f is given is 4 times 10 to the 14th. And I multiply those together, and I get the energy of the photon to be 2.65 times 10 to the minus 19th joules. I might even draw that on here. E is 2.65 times 10 to the minus 19th joules. And I know that electrons are going to be emitted because that energy is greater than that work function. So, yes, it's emitted. Because the energy of the photons is greater than the work function. Now, it says it wants to find the speed. In order to do that, we have to find the kinetic energy. So we can say the kinetic energy of the electrons has always been the difference between the energy of the photon and the work function. The photon gives up all of its energy, some to overcome the work function, and anything that's left over is kinetic energy of the electron. So the kinetic energy of the electron is going to be 2.65 minus 2 times 10 to the minus 19. And that's going to give me 6.5 times 10 to the minus 20th joules. Okay, now I need to find the speed. I run out of room over here. I can do KE 1/2 mv squared. Take that kinetic energy and put it in over here. So 6.5 times 10 to the minus 20th is 1/2. M is the mass of an electron, and that's on the reference table. 9.11 times 10 to the minus 31 times v squared. And if I solve that, I'll end up with a velocity of 3.78 times 10 to the 5th meters per second. It's a really high velocity, right? 378,000 meters per second. But that makes sense because electrons have such a small mass, they can go very fast. The thing to remember is that these are always conservation of energy problems. If you have something that's not an energy, like frequency, you have to find the energy